Example 5, sketch a graph. Sketch three different functions, each of which has a limit as x approaches 4 of f of x equals 2. So that means when you go over to 4 on the x, the y value should be 2. So let's draw three different ways this might happen. So one possible way is if we just go 1, 2, 3, 4, and we go up 2, and make sure there's a point there, and you can really do whatever you want to the left and the right, as long as the x value has a y value of 2. Now, what else might happen? Because it's a limit, it doesn't have to, the function value doesn't have to actually equal 2. It just has to approach 2. So we could go 4, 2, and there could be a hole there. There could be a hole there. That still has a limit. What about if we go 1, 2, 3, 4, up 1, 2, and there's a hole, but possibly the point moved somewhere else. So this still has a limit of 2. Even though the y value is at -1, the limit is still at 2 because both the left and the right side are approaching +2. So there are three graphs. On all of these problems, if you think you know what you're doing, please try them on your own before you watch the video. Find the limit using a table. In example 6, we've got the function absolute value x minus 5. And we want to find the limit as x approaches 2 for this function. And since they want us to use a table, we want to pick some values that get close to 2. So let's pick maybe 1, 2, and 3. We can get even closer and do 1.5, 2.5. Let's go ahead and draw our table. So we know what the x values are doing. They're getting close to 2. That's what this tells you. So let's pick some x values that do get close to 2, like 1, 1.5, 2.5, and 3. We want to go smaller than 2, larger than 2, but get close to 2. And then we want to just plug these in and see what the y values would be. If I plug in 1, I get -4, but the absolute values will change it to +4. If I plug in 1.5, I get -3.5, but the absolute values change it to +3.5. If I plug in 2, I get -3, but the absolute values will change it to +3. If I plug in 2.5, I get -2.5, but the absolute values will change it to +2.5. If I plug in 3, I get -2, but the absolute values will change it to +2. And we see that this limit actually has a function value of 3. And so that would be your limit. But just to make sure, you want to make sure that your function values were getting close to 3 from the left and the right. We can see that these function values are getting smaller towards 3, and these function values are getting larger towards 3. So 3 is our limit. In example 7, go ahead and try this before you watch the video. But if you have tried it already, you've got a rational function where you've got a polynomial in the numerator and a polynomial in the denominator. And you always want to start off evaluating your limit by just plugging in the number and seeing if it works. So if you plug in 0, you'll get 0 plus 0 plus 6. So we get 6 on top, over 0 minus 9. So you get -9 on the bottom. So your answer will be -6/9, which reduces down to -2/3. So the limit is -2/3. If you plug in -3, you'll get +9, -15, and 6. On the bottom, you'll get +9 minus 9, which is 0, so it doesn't work. So here we have an undefined denominator. Well, you can't divide by 0. So we are going to have to factor the top and the bottom and see if we can get rid of this situation that we have in the bottom where we have 0. So if we look here, this is what that first problem part was. And here we've got a situation where 0 is in the bottom. So what we want to do is factor the top, factor the bottom. So on top we have x squared plus 5x plus 6. So we want to find multiples of 6 that add up to 5. So that could be 6 times 1 or 2 times 3, and in this case it's 2 and 3. On the bottom we have x squared minus 9, and that is a difference of 2 squares, so that would factor into x minus 3, x plus 3. And then what we see is the x plus 3 is in common, so that will cancel. And so this is what is left to evaluate our limit. We then just take negative 3 into the remaining factors. And we have negative 3 plus 2, so negative 1, over negative 3 minus 3, or negative 6. And so we have positive 1/6 is the limit. Now what we would see in a graph is that the left and the right side of the graph go towards 1/6, but there is a hole in the graph because there was a 0 in the denominator. So it will be an empty point, but the y value of that empty point will be at 1/6.